So as you probably know, radios don't come much more reliable than the Maxon chassis used in, well, amongst others, the more unusual Maxcom Apollo 16E. Now we've got a scrap chassis here, which has a fault I've not come to the bottom. There's a limit to what kind of time you want to put into resurrecting scrap chassis. I can't quite remember where I got to with it, but it's got some poorly fault. But another set we either bought or was passed on to us is this. And we try and get the lights on the case top. You can see it's probably been in somebody's garage for quite some time. So Mark has tested this, and he says no receive, low power switch. I don't know. Low power switch. I think he must mean dodgy low power switch, and it says transmit's okay. So what we'll do, we'll go through that. We use a standard replacement mic, which is one of the few ones which is commercially still available with a 5-pin DIN on it. And as I say every time, if you come across these type of mics for sale, they're one of the few with a screen lead these days. There you go, MP520P3, we can sell them. Otherwise it's ones we have to put a metal plug on, which is of course a bit more money. But if you've got something like a Sapphire X4000 or the same Barracuda HP 940, the SMC Oscar 1, these are all sets with 5-pin DINs, but the Cybernet sets with 5-pin DINs, they are a different pin out. There's actually 2 wires have to be swapped round. So don't go buying one of these if you're intending it for one of those. We can always supply a standard replacement mic wired for those kind of sets. So that is the first thing. So this is Maxon standard. So the Midlands, the Baby Midlands, is the same pin out, but not the 77805 Porter Pack. That's a different pin out. And then if you move on to the DNTs with the 5-pin DINs, they're different again. And the LCLs are also different. So there you go. There isn't a standard mic connection anyway. Never was. One of the viewers has kindly sent a box of mics. He's sent stuff before, so thank you for that. We've got an Intec one. We've got, that looks like a Denita one. We've got a nice standard replacement mic. And we've got a Maxcom MX21E. I was hoping, because I've got an MX21E, put those somewhere where they don't fall. Now these do suffer from the inserts failing, and this is probably one where it works okay. So it'd be really nice if I can get this set to work. We'll do it with the standard replacement mic, and then if we get to an on-the-air test, we'll compare it with the factory original mic. So it is a problem because nearly every one of these the inserts failed. And I noticed somebody got the same Maxon mic at on an international sale in the United States, and he wanted something like $45 for it, and of course, huge amount of postage. But it won't be working. I wish people would test things. It's not. I mean, when those sets were new, they came with a 2-year warranty, and the mic came with no warranty whatsoever. So it tells you, doesn't it? I'm really pleased to get that, so thank you. I've got a Maxon 21E. In fact, I'll go and get it off the shelf. So when that mic arrived yesterday, I thought, you know what, we'll not get a case because I bought it as a scrap chassis. But I thought, you know what, we'll do this with that mic. And then hopefully somebody will say, hey, we've got a case which you can sell you. But you know what? It's been robbed of so many parts. And it's not so much that, but the audio chip's been ripped out. So if we just zoom in on the printed circuit board, if I press the right camera, let's just find where the audio chip is, you can see it's been ruined. So it's a real shame. They're nice radios. So basically it's the same as the Maxon 20E, but it has this extra board here which has the fairy light display. So instead of having the meter, it's a Texas Instruments fairy light display. So we're missing the audio chip. What's that? Is it 724 used as a speech processor? If it wasn't for that, you know, I could probably bridge some wires across and make that work. But the next problem is we haven't got the heatsink because somebody's nicked it. So it's there's an L-shaped bracket. So I need a Maxcom 20E or another 21E to try and make that up, which is a shame. So I bought it as a scrap chassis, and you know it is a scrap chassis, but I'm not going to take anything else off it in case it can ever be resurrected, because I do like those sets. So this is a nice candidate for somebody to respray, though it won't be offered for sale at this point. Might be when I retire. So I'll tell you what, we'll go inside this first before looking at the parameters, because you never know whether there's something obvious. I'll just put the soldering iron on because we're probably going to need that. I got halfway through doing a Sony Mavic video yesterday. I've not done a Sony Mavic camera video. I do want to cover all the Mavic models, seeing as we've got every single one of them. And we will not be starting with the FD5, which was the first one, but far from being the best. It's got a bit of wiring there. See whether my smouldering bat's warmed up. So this is one of my own sets, of course. It's not a customer one. I don't think we've got any customer repairs at the moment, and that's fine. Not looking for any either. But then we're not turning any away. I'm still not 100% health-wise with this ongoing chest infection. I had a hospital x-ray yesterday. I got to the hospital 25 minutes early, and they saw me within 10 minutes. I walked back to the car in the car park. This is Grantham Hospital, and it was 29 minutes past, so it was a minute short of my appointment time. I'd been done, and they do have a car parking fee. They have a car parking fee, but your first 30 minutes is free. I was only 16 minutes from parking the car to getting back to it, so I had nothing to pay, which did help when you're on a tight budget. So there you go. So they're going on about NHS queues and all that, but it depends what you're having done, and it depends when you are where you are, doesn't it? I'm in the middle of nowhere, and the hospital's 7 miles away, and it's not a 24/7 hospital, but it always seems to attend to me pretty promptly. I remember falling down and cutting my hand on a Sunday morning. I got out of the bath, slipped, and ended up cutting my hand. And as a church organist, you know, that's not good. Anyway, quickly got dressed, got in the car, drove myself to hospital, and I said to the triage nurse, because the triage nurse saw me within 10 minutes, and I'm going back about 10 years. And she said, oh yes, we'll get somebody to put some stitches in. I said, the only thing I'm saying to you is it's now 8:30 in the morning. I'm a professional church organist, and I'm on in an hour. And you know what? I was dealt with in 10 minutes and back playing the organ. So yeah, it does. It works for me. Right. So we will connect our extension speaker. This could be just a dodgy switch, could have been messed about with and wired wrongly, but at least we've got that other one to look at. So we'll plug in our standard replacement mic. You know what, I'm looking for PA on this, it doesn't have it, does it? Okay, so we've got an FM hiss. It's currently on channel 31 because Mark's just tested it to our. We've got that Fidelity 3000 in a cupboard in our hallway, and it's connected to the Tango amplifier. So anybody who wants to try a radio, just put it on 31 and talk to yourself through the PA system. There's 20 odd speakers around the place. You should hear yourself. I don't know how it'd be funny if this works and I demonstrate that. It is transmitting. I've just gone 31. Testing 1 2, testing 1 2. It's not loud enough in here to come over the microphones, but it was definitely coming through my background music speaker elsewhere in this room. Right, it's transmitting as Mark says. So I think it is time to get one of our sheets out. Of course, you couldn't make it up, could you? Because there's none printed off. Okay, back into record, and we'll switch picture in picture, and I'm telling you that so you know I've done it. So if it doesn't appear, that's the box of mics moved itself 6 inches, and it's doing 4.1 watts on channel 20. Channel 40 is doing 4 watts. Channel 1 is doing 4.15 watts, so it's not quite balanced. I'm sure we can do better. Low power, Mark says, isn't working. What on earth is happening? So I've switched it to low power. We now get a line in the window, go back to normal, to low power. Let's look at the frequency, just make sure there's no silly shenanigans. So we'll start our frequency, which is fair enough. It's 27,79094. It's not illegally off frequency, but we'll hopefully be able to bring that up. Just press that switch to make sure it doesn't do something silly. Yes, it does. It's been turned into a channel 19 switch, hasn't it? How clever. Not. Just check channel 1 is channel 1. So there we have channel 1, which is more or less what we'd expect. And then we go to low power, and we've now got channel 19. Okay. Low power switch. I'll put down as faulty. And that's why we've got 2 wires there which are taped together which say high low power. Luckily we've got that other set and we'll be able to look at that. The person with that CB1100 has asked me to take some high quality photos of our CB1100, which I will do. And at the same time I'll take some high quality photos of this, because our other 16E's got bits missing, so we'll kill 2 birds with 1 stone. So I'll make sure we've got a really good quality camera charged up. So normally I'm using the Mavicas, and you know, VGA resolution isn't good enough for people looking at component values, so we'll put one of the other ones on. Right, so that's not working. transmit current. Let's go to the right channel and take it to 20, and we've got 1.16 amps. That's quite good for what it's doing. We've got deviation. Wallow, it says 3.8. I'll tell you what we'll do. We'll do the deviation with the other test set right now. I'll just go back to that meter, just show you go. Wow, it's just going over the 3, just in case this meter's playing shenanigans, which it can do on the deviation because it needs the capacitors doing, and I can't be bothered. So we're not changing the test set on this bench. To dig that out and do it, we're talking about 2 days' work. Right, I'm just looking at the meter, deviation meter now on the other test set behind me. Wow, it's 4.5. So we'll set that here and now. It's going to be that one. The silver plated, these real thing. Wow, it never is that one. That must be squelch. Surely not. Oh dear. Why is... Oh, of course it's there, isn't it, on these? It's that one, isn't it? Look. Good. So I'll just plug back in, having now upset the squelch. Right, let's see what the Marconi test set now says. Wallow. It says actually reading right. So it was, what did it say, about 4.7 or something. Anyway, it's 2.2 to 2.5 kilohertz. Now remember, as I say this every time, this is width, it isn't how loud it is. It gets to the point when it gets so wide it's going on to several channels. So only people with really poor filtering are actually going to be able to hear it if it's too high. So I'm going to put the little walkie-talkie on. Testing 1 2, testing 1 2, testing 1 2, testing 1 2. So that's our standard replacement mic. So the mic that's been kindly sent in to us, let's see whether it actually works. Testing 1 2, testing 1. It certainly does, so that's really good to have. So once again, thank you for that. Right. The reason I call walkie-talkies talkie-walkies, we had a customer when I was at Nottingham Radio, and they phoned up, we wanted some walkie-talkies over the weekend for some event. This is business radio, it's nothing to do with CB. And do you do them talkie-walkies? Yeah, we do. Yeah. Another customer came in, and Mr. Smith, the owner, was there, and he dealt with the customer. And he came out with these walkie-talkies for the hire for the weekend. He said, I don't want those, I want the big Zanussi models. What? Oh, very well then. Goodbye. I don't think Zanussi have ever done walkie-talkies with business radio or anything like that. How bizarre. Right, before we go any further, we'll tune up the transmitter. So, at the moment, it's doing too much power. VCO we're not touching, and in any case you need to add extra components. I'm taking the bottom off usually to be able to read it properly. In manufacture they don't put those parts in because it's aligned on a pin jig. So that's where an unfinished board is pressed onto a jig that has got all connections which go straight to the printed circuit board, and they align the set without any of this wiring, and so it just works for them, and they don't need to put some of the parts in. So it's a cost-cutting exercise, which of course means as a customer you're not like being ripped off. It means that those 5 parts they haven't had to put in, so if they were tuppence each you haven't had to pay for them either. So we want the peak of the centre of the peak, that was already about there. That was already definitely there. That was there. This is alright, isn't it? That wasn't quite there. So it's now doing 4.6 watts. So that's no good to us. And we'll end up with the guppo coming round. That's when it was the GPO, isn't it? The guppo. With their detector van and its spinning roof. So peak on that one is 4.5. We're dropping now as the set's heating up. And then the actual power adjustment is done on the final one here. And hopefully we can drop that to 4. We can. So we're spot on the 4 now. I'm just going to check this doesn't have any sharp protrusions. Nope. So on channel 40 we're doing 3.9 watts. On channel 1 we're doing 4.1. Now then, let's see whether we can just trim that a bit more accurately. So that's 4 and a fraction. No. Let's try it on that one. We've got 3.95 on channel 40. Got 4.05 on channel 1. And we've got spot on 4 on channel 20. So that's good. And our transmit current is 1.03. So you can see we're tuned better because we've only dropped 100 milliwatts and yet we've come down 100 milliamps, so that's good. Let's just do the frequency. The test gear's now been on half an hour. So let's show you the frequency counter. Right, that's now spot on. So when we press transmit, we should have a number of fairy lights. I don't really want them all to come on. So deviation was second one down. Transmit meter is the top one. So I want it to be on the 4 because that's what the set's doing, but not quite on the 5. And then we know from the, because when we actually put it on an aerial, it won't be reading that. It'll be reading true when it's in a dummy load like it is now. So there we go. We've got that set. So it was showing 5. It's now showing 4. So that's correct. So let's go over. We'll just cross PA off. It's a Maxon that doesn't have that. It does sound a bit strangled. Not that we've heard any receive, but Mark says it. Did Mark says it receives? I can't remember. I didn't move the set. As you know, we supply these connectors and the power leads that go with them, and they're not fake mouldings. They're the manufacturer's current stock. They're not new old stock. They are current stock. Though where we import them from, it takes 9 months for us to get them, so I have to try and predict how many we're going to sell in a year. Believe it or not, it's about 200. They're all going somewhere, aren't they? Right. Let's put it on. Put the signal generator on to 79125. There we go. We've now got 100 microvolts on the signal generator, and we've got no receive. I've now got full whack on the signal generator, and I've got no receive. So we don't have any receive. Now if it was out of alignment, we would have something. So it isn't out of alignment. I'm sure if we twiddle any of this, we're not going to get anything. So it's dead on receive. Right, well I'll have to look at the circuit diagram and take this bottom lid off. Now these sets don't suffer from dry joints, they don't suffer from duff capacitors. But you never know. There you are, got a dry joint, haven't we? What I'll do, I'll pause the camera and then I'll have a look round very carefully and I'll show you before I correct it. So when I prod it, we are showing as there. So I'll tell you what we'll do, we'll unsolder that. It doesn't look like it's a problem. I'll do the next one to it, and we'll do this one as well, which actually looks more iffy. I'll do that one as well. So what we're not doing is just adding solder. We're actually going to unsolder it, clean the component, and then resolder. Right, switch back on. See whether we can make it go off. Oh, that's one Mr. Chippy's not had to see. Okay. So we don't know where the alignment was before. So the thing to do is to start from scratch. I'll put up the oscilloscope. I will. And we'll get maximum recovered audio. Which is there. Right, we'll go to SINAD meter. At the moment we're getting, I'm not going to write it down because it's not fair. It's a very poor 2.3 microvolts. So it's about on a par with the Cobra 29, which I bring up every time. Should be 1 microvolt or less on the Maxon. Can't kind of quite go where I want with the signal generator yet. The set is still too deaf. It's 1.5 microvolts for 5 dB SINAD. We need to bring it up a bit. So it's not that one that's out. Well, that's helped, hasn't it? So we're now at 0.5. Peak on that. Drop the attenuator again. Let's start at the beginning. Bit more signal for the IFs. There we go. There aren't any others on this. There's an extra circuit on some of the other sets. Right, so let's read off what we've got. So for 12 dB SINAD we've got 0.48 microvolts, which is excellent. So we have done, it was a dry joint, which is very unusual on a Maxon set of this chassis. So for 10 dB we've got 0.44, and for 20 dB, if it does it, oh, it's just doing it at 1 microvolt. Now squelch I messed up, so we'll just have to set it without what it was before. So 100 microvolts, just put this on the attenuator so you can see where we are. So for 100 microvolts, just move the camera across a little bit. The mice have moved it overnight, like they do. We're at 100 microvolts. I want the squelch to open at that point. There we go. So we're at 30, it's dropped off. 100 it's come in, so that's full squelch. So we'll now set to threshold. So signal generator off, signal generator to standby at 0.3 microvolts, threshold on the radio. There we go. Switch the signal generator on. Let's see where it comes in. 0.65. Good. Now, put 100 microvolts back on the test set. I think we'll switch picture in picture off. And we want it to show S9 on the fairy lights. If there's a preset. Yeah, now here we go. That's going to be low power. So it doesn't look to me like we've got a preset for the S meter. So at the moment it's showing 220 for S9. Right. Put that on one side. I'll look at the circuit diagram and then we'll look at mine and see what needs rewiring. So, I'll just unplug the mic and make it a bit more easy. So whatever's on that switch at the moment, I'll just disconnect everything and make it easier. So on our genuine one, all we've got is the brown and the red, and they're wired double poled. That's it. So our brown and our, you can see they go to the low power preset, and we can see that the brown, did I say orange? I said red, didn't I? I meant orange. I know I'm colourblind, but not that bad. So we need to get rid of all this daft wiring. Goodbye, daft wire. And then whatever they've got here. It may be that these two black wires have to be connected together to reinstate normal operation. So we'll see what happens. I'm not delving into how they've achieved this. We've got an extra wire in sleeving to a diode. I'll just snip that out. Link the two pins across. And solder these wires. They've got, it doesn't matter which way around these go, but we may as well replicate what originally was there and put orange to the centre. And brown to the side. So that's got that wired. Now, let's see what they've done here where they put this diode in. So in this original one, we've got 1k resistor just going across from one end to the other, and here they've done it via extra shenanigans. Hopefully I can get down to that. Yeah. Can we get the desoldering tool down there? What I don't want to do is melt any wires. Yep, done that. And then put this resistor back where it should be. There we go. So now, when I power it back up, it may not work. So I am prepared for that. So it may be possible I've got to connect these two black wires together to make the display come on. I'm going to plug the mic in because it may well be receiving, but we can't hear it. And that's, of course, because I've not got the extension speaker plugged in, and I've got the mic plugged in. Yeah, those two wires have to be connected together. Just plug the aerial back in through to the test gear. Yeah, so it does work, but there's no display until I put those two wires together. So let's just see what they've done. So we've got on our set here, the black wire goes to exactly the same place. Yeah, I'll just turn it off again. Now they've damaged the print on that one. Let's see whether I dare reinstate it from the correct side. And the answer is no, the print's completely gone. So, we're going to have to wire it somewhere else. Maybe enough, and maybe. Let's just put a bit more out. It quite clearly says on the board ground. So although that's now soldered to the ground track and we're all lit up, what I don't want is the weight of this wire to cause any of this track to come away. So I think the best course of action is to get the hot glue gun out and to just put a blob there so it's got mechanical rigidity. But there we go. Now hopefully we've got low power. So when we press transmit now, let's go back to the main, put picture in picture back on and go to the main meter. So now we're in low power and it's 300 milliwatts. Well, it's exactly where it was left before the silly modification. So we want 400 milliwatts. I don't like to see these with wax in, that's not good. Now we have 400 milliwatts. Let's check we're on high power. There we go, 4 watts, excellent. So low power's now 400 milliwatts. There we go. So we're all back to standard. I'm going to put it on the aerial at this point because, trust me to get a bit of wire in my mic, because I want to do that glue gun thing, and I'll do that in 90 minutes time, but I'll finish this video. So that's another nice set restored. I'll take it off the test gear and put it into the extension speaker on the wall. Well done, Roger. Roger. No, they're all having an afternoon nap. Right, well, we'll do an on-the-air test later on. We'll test both those mics, this one and the factory original, although it says Maxcom 21E on it. It is exactly the same mic that was originally supplied with these sets. It just said Apollo, didn't it, on it. I'm glad we've got to the bottom of the dry joint. In fact, we'll be leaving this on overnight just to make sure that it is fixed. And this set was going to be photographed, this set's going to be photographed, so that if there's anything missing from this one, we've got that to look back on. And at the same time, I'll do Matey's CB1100 photos. So there you have it, Maxcom Apollo 16E, silly modification, and unusually a dry joint. Thanks for watching.